Hello everybody! Today I'm going to explain how to solve the problem powered addition from the Codeforces Round 633. This problem is the problem A in the division 1, however it is the problem C in the division 2. In this problem we have to find the smallest number t such that we can make the array non-decreasing, and at some second we can add 2 at x minus 1 to some position in the array, and we can also not do anything at some second. This observation stated in the problem statement is very important because it helps us to actually see if we can do it with at most t additions. Basically, for some t, we can literally simulate a greedy process and see if we can actually do the job. Now let's move on to more details about how to solve the problem. Here I'm going to write the first sample. This is an array of length 4 and it has the elements from the first sample of the first test case. Basically, as I said, we will simulate for each possible number of t if we can actually get the array to be increasing. For t equal to 0, basically not do anything, we can't do it because the array won't be increasing. For t equal to 1, we can add, let's say, 1 to 6 and 5, but it won't be enough. For t equal to 2, however, we can actually add 1 to 6 and let's say 3 to 5, and we get the array to be increasing. Since we got the okay verdict for t equal to 2, we can also make it okay for t equal to 3 because we can literally skip the move at the third second, and so on for t equal to 4, 5, etc. What does this mean? Well, if we can actually perform the algorithm after some number of seconds, we are sure we can always perform it at some bigger number of seconds by skipping the bigger moves. What does this mean is that we can binary search the answer and check for some position if we can actually do the job. Basically, we can do the job if for each number, the difference between that number at the value of the previous number after doing this algorithm is less or equal than 2 at t minus 1. Because at t equal to 1, we can add 1, 2, 4, and so on. In order to make things even simpler, we can observe the fact that 2 at 30 is already quite big, like over 1 billion. And this helps us realize that the maximum answer is not too big. So we can actually simulate for each second what does the algorithm do, and we can determine if the algorithm is good enough to perform in t seconds for each possible t. Now I'm going to move to the implementation part. Basically here I have created another array which keeps the values from the original array, since my algorithm relies on modifying some of the elements from the array to check if some step is good. Basically, in the array tk, I memorize the bits which we can use. This is a leftover from my initial reading of the problem because I thought we need to minimize the number of moves made. And we must always reset the array to the original one. For each number, if the number is already bigger or equal than the previous number, we don't do anything. Otherwise, we will see if we can actually get the number to be bigger than the previous one. If this doesn't happen, we can't do it in the next 80 seconds. So we need to break the algorithm. Otherwise, let's say we can do it. But we can't just let the number be added by all the powers of 2 possible, because this may make us not be able to do the algorithm for the next number. So we need to run a greedy approach, which basically uh, asks us to find the smallest number necessary in order to be at least bigger or equal than the value on the previous position. Since the steps are always powers of 2, we can do this with greedy, and it will always lead us to have a number equal to the previous one. And in order to ensure the correctness of the algorithm for the following steps, I have assigned the value of the current position to the position obtained after the algorithm. If at some step we didn't get anything wrong, we can just set the answer to be the value of the current step, which is max ID, and then we have printed the answer. It turns out that this problem is actually a simple greedy exercise, but you still need to observe some insights in order to be able to solve it. If you liked watching this video, please like the video, subscribe to my channel, and press the bell button in order to be the first one to get notifications about the new videos. Also, you can join my Discord server in order to always be notified whenever I post a video. Until the next time, stay safe, stay healthy, good luck, and goodbye.